it. But a lot of people do find before practicing, they do find reading time quite, you know, I guess a bit tedious and it feels a bit long. And especially if you look at exam one, let's say, the exam one for VC methods, it is 60 minutes of writing and 15 minutes of reading. So 60 minutes writing and 15 minutes of reading. Now, if you kind of think about that from a ratio standpoint, I mean, you don't have to calculate this ratio. I can just calculate for you. This is 1 to 4. So 1/5 of your exam taking time is actually just reading time. And if you think about it like that, if you think about the exam being 1/5 reading time, and you think about the exam being 75 minutes, then reading time is actually really crucial for people to make the most of and to understand the questions. So if you went through reading time and you felt as if that you're just kind of reading things blindly and you weren't really taking note of what was going on, it's actually really crucial to make sure that you have a really good understanding of the questions and what it's asking you. And so then when you go into writing time, you could pretty much just go straight into the questions. And that's why with how I work with students just generally, I like to do these types of tests where we're doing these timed things on a regular basis because it means that we can actually expose ourselves to practicing reading time, making the most of it. And when we go into exams and we go into SACs, it doesn't feel as difficult. Does that make sense to people? Does that make sense? Yep. Yeah, I see some people nodding their hands, not raising their hands and nodding their heads. I really appreciate that. But yeah, that's why reading time is super crucial. And that's why whenever we do these assessments and these practice tests, I like to dedicate some time to reading time, even though it can seem a bit tedious at first. Now, I don't want to make you go blindly in the test, so we'll do a little bit of just review of what's going on. Can people see my screen with the questions on it? Perfect. Cool. So I'm just going to do like a little bit of a run through of question one, but not walk through it, but just before you attempt it, I just want to make sure that we kind of got everything understood. So we have two different functions. We have f and we have g. Now, the skills, I'm just going to go through the skills required for this question. The skills required for this question are purely composite functions and also our functions knowledge from last year. So I presume a lot of people, they would have done logarithms already and they would have done circular functions already. So this is building upon that knowledge, but it's specifically applying the skills of composite functions. Now, hopefully you guys did watch the videos before the class because that's really crucial in order to answer this question. So if you haven't watched those videos, this will be a bit of a challenge. If you have watched the videos though, this will probably still feel like a challenge because these are more application style sort of questions. So there's 6 marks in total. So there's 2 plus 2 plus 2 for each of the different parts here. So this should be 6. So if we divide out the 21 marks in total by the 30 minutes given, 6 marks would roughly be 9 minutes. So what I'm going to do is I'm going to just put the timer on for 9 minutes and we'll just do question one in this 9 minutes. So just give an attempt of question one. So 900. Give an attempt of question one, do it completely, review it if you have time. And if you don't have time to finish it all, just attempt as much as you can. And we'll be running through it right after the 9 minutes is done. Awesome, everyone. That's it for this question. That is it. That time went fast. That time went extremely quickly for this question. How did people find that question? Maybe just put it in the chat. Thumbs up reaction, thumbs down reaction. What do people think? Difficult, difficult, hard, difficult. Yep. Thumbs up. Someone gave the thumbs up. So someone found it not bad. That's good to hear. Cool. Okay, so it looks like most people found it difficult. That's the intention with these questions anyway, and that's why I get my students to do these ones on a very regular basis, like twice per week. Get Friday hard with the crying emoji. That's cool. Yeah, so most people found it difficult, but that's the point of doing it now, right? So what's the date today? It's 2nd of December. If you're exposing yourself to these types of questions from now all the way up until your exam, which is early November, there's there's nothing stopping you from actually learning how to do these questions, but not only learning how to do them, but also doing them quickly as well. Because one thing as well is that when I came up with the time for this question, I said, was it 9 minutes or something like that? But if you're doing a test and you're doing a SAC, you want to be aiming to do it in less time per mark because you want to have more time at the end to review your answers. So just keep that in mind as well. The time that we spend on these questions is just like the upper end of time that we should be spending, but eventually we want to like slowly we want to reduce it down and reduce it down over time, which will naturally happen. So anyway, what you guys are probably more curious about is how to actually do these questions. So that's what this class is all about. It's attempting the questions and then reviewing straight away exactly how to do them. And we'll just break down just in the simplest terms possible how to actually do these questions. So question one, let F such that domain one, so D1 is undefined right now, it's not given to us, is maps onto R such that f of x is equal to log e of x. So this is just defining f of x in this statement here. And then you have G such that D2 maps onto R, g of x is equal to cos of x plus k. So you have two different functions defined. And for part A, it's asking us to show that f of g of x is defined for x as an element of R when k is strictly greater than 1. Now, the first thing that comes to mind when it comes to this question is if I need f of g of x to be defined for its full domain, what I need is that the range of g is a subset or equal to the domain of f. This is the key definition or the key criteria that has to be met for a composite function to be defined, specifically f of g of x. So in general, I talk about this in the video, but I'll just give a bit of a rundown. In general, your inside function, the range of the inside function has to be a subset of the domain of the outside function. And I've explained this in the video that's on the online course as well. So I'd highly recommend checking that out because I do explain it in a lot more detail and I break down why that's actually the case. That's something I'm really big about as well. If you've ever watched any of my content, I'm always big about why things are the way that they are. So in the video, I talk about why, but now we're just going to use the criteria or the definition, which says that the range of G, which is the inside function, must be a subset of the domain of the outside function. So now we just work out those things. We just have to figure out what the domain of f is, and we just have to figure out what the range of g is. So we'll start off with the domain of f. It's log e of x. So if you guys have seen a log e of x graph before, it looks something like this. So we're just recalling some knowledge from last year. This is log e of x, and it's defined from 0 to infinity. So it should be round bracket 0 because we have an asymptote at x equals 0. So this would be from 0 to infinity for the domain. So therefore, the domain of f is 0 to infinity. So that's pretty straightforward. Now, what we need to do is we need to make the range of g equal to 0 to infinity as well. So what we need to do is figure out what the range of g is. Now, currently, we have cos of x plus k. So we need to figure out what the range is in terms of k. So if you remember your trig knowledge, what we have here is we have cos of x that's translated upwards by k units, or essentially the median line is going to be k, something like that. So this translation here will be k, the amplitude is 1, so this will be k plus 1, and then the trough is going to be k minus 1, because we're just adding and subtracting that amplitude. So that amplitude is going to be 1, that amplitude is going to be 1 as well. So therefore, the range of g is essentially just going to be k minus 1 to k plus 1 if we just want to put an expression on it. And we know that this k minus 1, k plus 1 is going to be a subset of 0 to infinity. I actually got a direct message from someone, isn't that a sine shape? Well, that's correct, but sine and cos are the same shape anyway. So I just draw the same curve because, yeah, the patterns of the peak and the trough in the middle is going to be exactly the same for sine and cos. So it's more so just a representation. No problem. Another question. If anyone has any questions so far, feel free to just ask me in the chat at any time. So I could just pause now and answer these questions. Someone asked, can we write dom in place of domain? I do, and I think it's fine. So I think that's okay. And it's when you write things down, you also just have to think about, does it make sense from an examiner standpoint? If people look at this, it makes sense that dom is going to be domain because in context, it just makes the most sense. So I would say that that's fine to leave it as dom f. But if you're kind of worried and if you feel like your teacher's a bit of a like a harsh marker, maybe just write domain instead of dom just to be safe. Just like an extra half second to write that. But yeah, good question though. Now, okay, cool. So right now we've established that the range of the inside function is k minus 1 to k plus 1. We found out that the domain of the outside function is 0 to infinity. So essentially, if we want this to be a subset or equal to, we essentially want k minus 1 to be at 0 or equal to 0. But we need it to be past 0 because we see the round bracket 0 there. So what we essentially say is that k minus 1 should be greater than 0. Essentially, we just want that this range here to be a subset of 0 to infinity. Now, that's a really critical step with this question. Does anyone have any questions with that? Hopefully that makes sense to everyone. I'm not sure if that, but I feel there's a couple of people nodding. If that makes sense, that's all good. If you have any questions, feel free to leave it in the chat. But that is the critical step with this question. K minus 1 has to be greater than 0 for that range to be a subset of the domain. And then from there, you just get k is greater than 1, which is what we were looking for in the first place. So therefore, what we can say is that f of g of x is defined for x is an element of all real numbers. And the reason why we can say it's defined for all real numbers is because the condition for the composite function was true. So therefore, we didn't have to do any restricting. We didn't have to do any restricting for the condition to be met. So if k is greater than 1, there's no restricting involved. Therefore, f of g of x is defined for all real numbers, which is the critical part of this question. So if we're thinking about mark breakdown for this part of the question, the first mark would be given to probably, I would say this statement here, and the second mark would be given to this statement there. So one statement that signifies that the condition for f of g of x to exist is that the range of g has to be a subset of the domain of f. And to be honest, if I'm a bit harsh with my working out, I probably should say for f of g of x to exist here. I can definitely add that in just to help a little bit more detail with my working out. So 1 mark for some statement along those lines, and then 1 mark for whatever formula you get or whatever equation that you get from these expressions here. Someone asked a really good question, even though they used the skull emoji to signify that they didn't do a good job. Is it okay if I sub in k is equal to 1 and k is equal to 3 and showed false for k is equal to 1 and true for k is equal to 3? That is a really good question, and this is something that we should nip in the bud right now. You can never do that when doing show that questions. Whenever doing show that, so this is really important for people to note down in general. For show that questions, you cannot use what's given in the question. You cannot use the answer that's given in the question. You have to derive that answer, and then you can validate it by checking the question. So for example, if a show that question also has show that a is equal to 3, for example, you cannot just substitute in a is equal to 3 and manipulate it that way and work backwards. You have to derive it from scratch and then get a is equal to 3 as the final answer. The good thing about the show that questions, though, is that if you do get that answer right, then you can check it and you know that you've gotten it right. So in this case here, if my working out is sufficient, I know that I'm going to get full marks for this question, which is good because I can just move on and I can rely on that for future marks. And even if you don't get it right, show that questions are really good as well because you do get given an answer. So if you can't solve that one and you need that to answer the future questions, then you already have that. Someone also, by the way, if people have questions, just ask it in the everyone chat, just because I want everyone to be able to see the questions as well. Someone asked a question and then they said disregard it. So okay, I guess I'll disregard that. Cool. If no one has any more questions about this, let's move on to the next question. When k is equal to 1, determine the maximal domain of G2 for f of g of x to exist. Okay, so now we're given a specific value of k. And this value of k, by the way, before we continue, this value of k is equal to 1, applies for both of these questions. And the reason why we know that is because it's saying that k is equal to 1 at b, and then it has subparts that are dependent on that. So because it has subparts dependent on that, that information that's given here applies to all the different parts, not just the following one. I know a lot of people do get confused with that. So what I would just want to be clear with is that if there's information that's given here, then it applies to all the subparts there that are following on from that. Now, determine the maximal domain of D2 for f of g of x to exist. So D2 is the domain of G. Now, what we know is, again, the condition for a composite function to exist, the range of G must be a subset or equal to the domain of f. And we found in the previous question that the domain of f was 0 to infinity. We found the range of G was k minus 1 to k plus 1, but in this case, we know that k is equal to 1. So we can actually just substitute in k because we have a general expression. So we know that the range of g is going to be 0 to 2, like that. Now, right now, what you can see is that in its current form, this is not a subset because we have a specific value 0 that's defined for the range of g that doesn't fit inside the domain of f. So this subset right now is not actually true. So I'm just going to put a line through that or a slash through that just to signify that that's not actually true. So what we need to do is we need to restrict cos cos of x plus 1 to get rid of the 0 values. So let's just get a visual representation of cos of x plus 1, and then we can restrict it from there. So cos of x plus 1 looks something like this. It essentially is a graph that goes from 0 to 2, and it scrapes against the x-axis of those specific points. Now, those specific points, what we need to do is just get rid of these points here. So if we just continue this pattern and find that pattern, we just remove those points, but it can be any other value, as long as we get rid of the 0 values in our range. Because what we essentially want is we want the range to essentially just be round bracket 0 to 2 rather than square bracket 0 to 2. Because if our range, I'm just going to write the ideal range just so we don't forget. If the range of g is equal to 0 to 2, then that's perfectly fine because it is a subset of 0 to infinity then. So that's essentially our goal with this question. Now, again, cos trigonometric knowledge, you might not know it. Now, the pattern for cos of x plus 1 equaling 0 is going to essentially be pi, 3 pi, negative pi, 5 pi, so on and so forth. I just kind of spoil that because a lot of people might not remember trigonometric knowledge. That's perfectly fine. The intercepts or the 0 values are given as pi, 3 pi, 5 pi, negative pi. Essentially, if you want to figure out a pattern, it's just odd numbers multiplied by pi. If we remove them from our domain, then the range is going to be round bracket 0 to 2. So therefore, the condition for the composite function is actually existing, and the condition is met. So therefore, f of g of x actually exists, because f of g of x only exists when this condition is true. So what we need to do is say that the domain of g is an element of all real numbers, and we just exclude all the odd numbers multiplied by pi. So if you want to figure out how to write that out, what we do is we write the odd numbers multiplied by pi as 2k plus 1 pi, where k is an integer. Now, if you kind of want to understand how this works, just imagine what different values of k are. So for example, when k is equal to 1, what does this equal? It equals 3 pi. When k is equal to negative 1, what does this equal? It equals negative 2 plus 1 pi, so it equals negative pi. Essentially, with all these different values of k, you're going to get all the different odd numbers multiplied by pi. So what I've done is I've just said the domain of g can actually be any other value except when we have an odd number multiplied by pi. So that's why I've used the backslash here, because I've used that to exclude that set of numbers. So this is your solution. So domain of g has to be all real numbers excluding 2k plus 1 pi when k is an integer. And this is a really key part of this solution as well, to signify that k can only be whole number, positive numbers or negative numbers, or 0. That's what the integers are. By the way, just before we continue, there is a lot of assumed knowledge with this stuff here. So if you are forgetting some things, that's all good. They're things that we'll refine and you'll refine as well. Nathaniel asked, can you explain why we only need odd numbers? Good question. So that's because the odd numbers multiplied by pi are where the intercepts actually happen. And we're trying to remove the 0 values to make this condition be true. So we're trying to make the range of g be a subset of 0 to infinity. And therefore, we're removing all those odd numbers multiplied by pi because that's the pattern. You don't have to figure... I think I said this before as well, but you don't actually have to know this right now. But it's just good knowledge and good practice as well. Someone said the circle and the back and the square brackets clash. I'm not sure what you're referring to. Yeah, I'm not sure what you're referring to. We'll move on. Part 2, hence determine the corresponding range of f of g of x. Okay. Now, just as a reminder, f of x is equal to log e of x. G of x is equal to cos of x plus 1. Now, we found out in the previous question, or we set in the previous question, that cos of x plus 1 is an element of 0 to 2. where we have a round bracket 0. So just as a reminder, what that graph looks like is something along the lines of this. So we have this shape here, but we've just excluded all of the different x-intercepts to prevent the zeros from actually happening. So they're exclusive circles there. Now, I've actually got a quick way of finding the corresponding range from a domain if you're given a function and that function's also one-to-one. So what we can do is, because we are finding log e of cos of x plus 1, if we know the extremes of cos of x plus 1, we can actually just log base e, both the lower bound and the upper bound as well. So what we can literally say is that the lower bound is going to be log base e of 0, and the upper bound is going to be log base e of 2. By the way, this does not always work. This does not always work. So just put this down with a grain of salt. This does not always work. It only works in this case because log e of x is a one-to-one operation. So I'm just going to do this to the side, actually. I'm just going to write this down. So log e of x is a one-to-one operation. What that essentially means is that when the x value is larger, the y value is always larger as well. I'll give you another example of that. X cubed is also a one-to-one operation, because whenever we have a smaller x value, we have a smaller y value. Whenever you have a larger x value, you have a larger y value. I'll give you an example of one that's not, just so you can kind of understand a bit better. X squared is not a one-to-one operation. And that's because when you have negative values and you square them, they become positive. So if you have, let's say, this x squared graph like this, right? And this goes from -2 to 4, and then this turning point is at 0, 0. The end point of the domain is not the same as, well, the starting point of the domain is -2. That is not the same as the starting point of the range, which is 0. And that's because we dip down and we dip back up again. It's not one-to-one. It's actually many-to-one. So log is not like that. Log is one-to-one. So we know that the lower bound of the domain will be equal to the lower bound of the range, and the upper bound of the domain will be equal to the upper bound of the range. Not equal to, but it'll correspond to. So log base e of 0 doesn't actually equal a value. It's undefined, but conceptually it approaches -infinity. So the lower bound of our range is actually just going to be -infinity. Log e of 2, that's of course a value. So the upper bound of our range is going to be log base e of 2. So therefore, our range is going to be -infinity to log base e of 2. And that's the easiest way of getting this answer there. I would say 2 marks for this one for the lower bound, 1 for the upper bound. It probably makes the most sense for this one. Awesome. I'll give you guys a couple of seconds just to note down anything that you want. And then after that, we'll move on to the next question. We're going to go pre-overtime today, but thank you for your patience. The next question is the longest one, so we'll get that one out of the way. I'll give you guys a few more moments just to note everything down that you want. By the way, I will be sending a recording of this, so if you do miss anything, you can watch the recording and you can see there. Now, the next question is the longest one. I'm just going to go to the next question. Next question is the longest one. It's 11 marks. So I'll be giving you guys 15.5 minutes for this question here. So give it a go. There's a lot of parts to it. The first parts are a little bit easier and it gets a bit harder after that. So I'll give you guys 15.5. Awesome, guys. This one is done. This question is done with the time. I feel as if for this question, the timing was a bit better. So this question here, it does involve a graph. And generally when you have graphing things involved in questions, you can save a lot of time, especially if you are good at graphing and you find it quite simple. And they're also worth a lot of marks as well. Because this graph here, part B, has a function, it has its inverse, it has intersections, it has the axis of symmetry as well. There's a lot of places to gain marks, but it also means there's a lot of places to lose marks as well. But if you do the graph correctly, then you're gonna secure all those marks. So that's what we're going to be trying to do with not only graphs, but all these types of questions. But this question I didn't feel was too bad compared to question 1. So we'll just quickly review it. The first couple should be pretty straightforward. We have f of x is equal to the square root of x minus 1 plus 1. We're asked to determine f inverse of x and state its domain. Now, it's just really critical whenever we find an inverse, we have to have some sort of statement that says that we swap x and y. That's really critical for inverse functions because we don't just want to blindly swap x and y. We need to make sure that we're actually specifying what we're doing. Because again, everything that we do has to be quite clear and intentional to the examiner. So I'm just going to emphasize this. Everything has to be very intentional for the examiner to see. So we don't just want to randomly do things. Everything has to be really justified. And I think someone sent a message in the chat. Someone said, "Can you say let f of x equals y?" Yes, I would. That's fine. But I would still say somewhere in there for an inverse or something like that. So I still make it really clear that it's for an inverse function. So anyway, we'll continue with this one. If for the inverse, we swap x and y. So we end up getting x is equal to the square root of y minus 1 plus 1. X minus 1 is equal to the square root of y minus 1. X minus 1 squared is equal to y minus 1. Therefore, y is equal to x minus 1 squared plus 1. So this is the rule. Now we need to figure out the domain. So the domain of f inverse is always just going to be the range of f. So we can figure out the range of this. It's quite straightforward. It's just a basic square root function that's translated to the right and translated upwards, that essentially just has a starting point at 1, 1, if you look at those values. So you can see the range here is from 1 to infinity. And especially, we know that also because we have the top half of the square root as well. So the domain of f inverse is going to be the range of f, which is 1 to infinity. Now, if we look at our rule here, we can see we have y is equal to x minus 1 squared plus 1 as our algebraic rule. We'll have to still specify f inverse of x. So make sure you don't have this as your final answer. This is just the algebraic process. But if you look at the rule here, you can see that the turning point is at x equals 1. So you can see based on the domain, we have it defined from 1 to infinity, which makes sense because we're taking the right side of the parabolic function, which corresponds to the top half of the square root function. So that's the inspiration behind that. And that's a good double check to use as well. When we do the graph, you'll also see it graphically, which is quite cool to see. You end up getting a nice shape that is meant to be very symmetrical. So for the final line of working out here, we say f inverse of x is equal to x minus 1 squared plus 1, where x is an element of 1 to infinity. And honestly, there's not too much working out here. It's quite a basic function. So I'd say 1 mark for the rule, 1 mark for the working out, for 2 marks in total. Someone asked a question in the chat. For your answer, would you technically write f inverse of x? Oh, yeah, cool. Thanks for bringing that up, Rudy. Yeah, so I just do it algebraically until I get y is equal to something, and then I rewrite it with f inverse of x with my final line of working out. Part B, sketch the graphs of f and f inverse on the axis below. Ensure to label any key points such as endpoints, intercepts, and points of intersection. Also draw and label the axis of symmetry between the two curves. Now, first of all, straight away, what is the axis of symmetry between a function and its inverse? This is a really critical thing that we should note down straight away. And it's going to be a really good baseline for us to just sketch at the start. So that's a pretty straight line. I respect that. So that's y is equal to x. Now, y is equal to x is going to be the axis of symmetry for any function and its inverse. So what I do all the time whenever sketching a function and its inverse is I just sketch this straight away because I know it's going to be a really critical part of my sketch here. Now, if we look at our rules, the first one is the square root of x minus 1 plus 1. So I'm just going to write that down. So f of x is equal to the square root of x minus 1 plus 1. That is going to have a starting point at 1, 1. It's kind of similar to our turning point form, where we take the negative of this value here and the positive of that value there as the x and y respectively. So square root of function starts off at 1, 1. And then the square root function will, of course, go upwards in its usual shape and then go to the side, kind of similar to that. Essentially, it's a sideways parabola. So just imagine it as a rotated parabola, and it's the easiest way to kind of think about it when you sketch. Now, f inverse of x was equal to x minus 1 squared plus 1. So that you're going to have a turning point at 1, 1. So it actually has the same starting point. And we'll talk about why that's actually the case as well after I sketch it. Now, don't forget that x is going to be an element of 1 to infinity. So we only need the right half of the parabola. We don't sketch the left half because that's outside of our valid domain. So that is going to look something like this. So this is going to be f inverse. I'm not going to write the full rule. I'll just label it like that. We've got f inverse and we have f like that. Now, one critical thing, someone's asked a question first of all. Why is 1 inclusive for F inverse? Um, 1 can be inclusive because we can have the square root of a zero number. So if you substitute in x equals 1, then you get square root of 1 minus 1, which is 0, which is still valid for our calculation. We just can't have negative values underneath our square root. Yeah, hopefully that makes sense. I see you nodding. Cool. Now, note how we started off at 1, comma 1. And then when I sketched the first graph, I sketched the second graph intersecting at the same point. This is really critical. This is one thing. If you're going to take two things from this video or two things from this class, the first one is the composite function rule or the composite function criteria for it to exist. The second one is that intersections happen along the line y is equal to x due to the symmetrical nature of our function and its inverse. I talk about it all the time in my videos. You've probably seen me, hammer it down before on Instagram, YouTube, wherever you watch my content. I always hammer this point home. It's that a function and its inverse always, almost always, very much almost always lie along the line y is equal to x. There's a very rare exception that I talk about with students, and it's only one example that I've seen before, not in methods. I saw it in engineering, but just note that if you sketch a graph and you can see that it roughly looks like the intersections lie along the line y is equal to x, it definitely does. And that is actually really crucial for this question, because if you try to solve x minus 1 plus 1 is equal to x minus 1 squared plus 1, essentially the function is equal to the inverse function, this is actually quite hard to solve because you have a square root on one side, you have a parabola on the other side, and it actually would, and someone just filled my words. They said it will turn into a quartic. Thanks, Nathaniel, for that. I was going to say that. It turns into a quartic, which is almost impossible to solve by hand. It will take a really long time. So as an alternative, what we do is we let either one of our equations equal x, and we just solve that equation instead. So what I'll do is I'll just choose either one will work, same as simultaneous equations, either one will work. I'll just let the original function equal x. So therefore, I get square root of x minus 1 is equal to x minus 1 if I bring everything across. And if I square both sides, I get x minus 1 is equal to x minus 1 squared. And if I bring everything to one side now, I get x squared minus 2x plus 1 minus x plus 1 is equal to 0. So you get x squared minus 3x plus 2 is equal to 0. It looks like I can factorize this. X minus 2, x minus 1 is equal to 0. In totality, I get x solutions at 1 and 2. So the first point is validated, which I put there. That's perfect. That's really, really nice sign. The second point is going to be at x equals 2. Now, the y value, of course, if it lies along the line y is equal to x, then we know that the y value is also going to be equal to 2 as well. So that would be my secondary intersection in this case. So 1 mark for each shape, 1 mark for the axis of symmetry, and 1 mark for probably just both intersections. And with graphing, I've noticed that with marking schemes, they usually deduct marks for missing features rather than adding marks for including features. It's kind of different to how other things are marked. So just keep in mind that if you do see strange marking on graphing, it's because they take away marks for missing features rather than adding marks for included features. But this is a pretty neat graph. I would say I'm not sure how you guys are sketching it, but in terms of how it actually should look, just make sure that your lines are smooth. Mine's a little bit shaky because I'm drawing it on the computer here, but just make sure that your lines are smooth and not kind of like jagged edges. That's a really crucial thing that I see a lot of people mess up with. Okay, so now we have this g of x introduced. G of x is equal to the square root of x minus 1 plus p. Now, part C is asking us to determine G inverse of X and state its domain. It's exactly the same as before. Inverse, we swap X and Y. The only difference in this case is that we have a parameter. We have P, but we go through exactly the same process. Just seeing a letter is not going to, we shouldn't allow that to throw us off. It's exactly the same process. We just kind of treat P as a number and we treat it accordingly. So X minus P is equal to the square root of Y minus 1. So we can square both sides. X minus P squared is equal to y minus 1. Therefore, y is equal to x minus p squared plus 1. Now, to figure out the domain, again, we can just figure out the range of this. So the range of f is equal to p to infinity. Now, the reason why it's p to infinity is because the starting point is going to be at 1 comma p, because we're translating up by p units upwards to get to our starting point. So therefore, the graph is going to look something like that. So therefore, the domain of f inverse is going to be also p to infinity. And the rule, I'm not going to write it again. I'll just write it up there. And the rule is, of course, going to be x minus p squared plus 1. It's kind of the same deal as before. We take the positive half of the square root and we end up left with the right side of the parabola. And I actually forgot to mention this before, but you can actually see that here. It's nicely validated because our shape is perfectly symmetrical. If we took the left-hand side, that wouldn't be symmetrical about the line y is equal to x. It wouldn't make any sense at all. So because we get a symmetrical shape about y is equal to x, it makes sense that the domain is going to be the right half of the parabola. Also, my nose is a bit runny, so if you hear me kind of congested, it's because of that. Now, part D, determine the value or values of P for which G and G inverse do not intersect. So this is quite a tricky question because what a lot of people would do, I kind of gave this away before, but what a lot of people would do is they would just try to solve G is equal to G inverse, and they would end up getting a square root function is equal to a parabolic function. But we don't want to do that because it's too complicated. What we'll do instead is we'll just let one of our functions, either the function or the inverse function, equal x. So I might just do g of x is equal to x. So what we'll do is we'll end up solving this equation, and then we'll try to include the condition for not intersecting. Hopefully we end up with a parabolic equation. And if we end up with a parabolic equation, then we can use the determinant and the discriminant and let it equal less than 0, or let it be less than 0. And that is corresponding to not intersecting. So if we have our inverse rule, it is x minus p squared plus 1. I'll let that equal x, and I'll just expand everything and move it to one side. So x squared minus 2px plus p squared plus 1 is equal to x. Therefore, x squared. Now I'm just going to group the coefficients together. So I got negative 2p minus 1. So when I move this x to the other side, the coefficient ends up becoming minus 1. So that's how I get that. And then we get p squared plus 1. Yeah, p squared plus 1 is equal to 0. So just as a side note, I wouldn't include this in my working out, but just for your reference, a is equal to 1, b is equal to negative 2p minus 1, c is equal to p squared plus 1, just to have everything clear. Now, what we do is, because we have a quadratic equation, which is perfect, because if we want no intersections, then we just let the discriminant be less than 0, which you might remember from last year. Hopefully it's coming back to you. So delta is less than 0 for no intersections. Therefore, b squared minus 4ac is less than 0. And we essentially just solve this equation for p. So b squared is going to be negative 2p minus 1 squared. By the way, negative 2p minus 1 is the same as 2p plus 1 all squared, because when you square it, you get rid of the negative anyway. So I'll just write it like that because I don't know about you guys, but I don't really like dealing with negative numbers. Minus 4 multiplied by a, which is 1, and then by c, which is p squared plus 1, is less than 0. So I'm just going to expand this quickly and trying to get rid of the boring stuff. Minus 4p squared minus 4 is less than 0. So we can see that this expression actually cancels out quite well, because we have 4p squared minus 4p squared. So we're actually just left with 4p minus 3. That should be minus 3 is less than 0. And if we rearrange this equation for p, we end up getting p is less than 3/4 for no intersection. Awesome. Cool. I'm just out of curiosity, how many people got this question right? Maybe just give me a thumbs up if you got it right. Awesome. Yeah, a few people. That's really cool. That's really cool. And it shows a lot of knowledge from last year as well. And that's good. You've kind of recollected that knowledge, and we're very consolidating it right now. But for the people who didn't get it right, what I would say is that it's not super you're not in a bad position or anything, because as I said, it is 2nd of December and you have plenty of time to learn these skills. And these are skills that not only you should be going through in class, but it's what my class is going through at the moment as well, or like my group of students is going through as well. We're going through all the content from start to finish, making sure that we do understand everything thoroughly. And hence that's why we do these tests. And that's why we have all the online content as well to help you learn it, everything. Because I know if you look at a year 12 curriculum, they do skip a lot of things. So we just want to make sure that we're covering everything as thoroughly as possible. Cool. Okay. Last question. The last question is a bit of a quick one. So it's only 4 marks. I'll give you guys around 5 minutes to do that one. So we'll just jump into that last question. Again, it's pretty straightforward. It's more so just to practice your algebraic skills. So I'll just give you guys 5 minutes and we'll get started with that now. Sweet. Okay, that's the end of question 3. This one, in terms of the difficulty, I wouldn't say is as hard as the other two, but it's more so just the time restraint with this type of question because this one is just a 1 marker, this one is just a 1 marker. It just naturally means that these questions have to be done pretty quickly. So we'll try and zip through that as well. So we have F such that 0 to C is an goes into all real numbers. Essentially, if you don't know functional notation, this is just the domain there. So the domain of this function is going to be 0 to C for f of x is equal to 1 minus x squared. And then g function is the domain is unknown right now. And we're given that as g of x is equal to the square root of x. Now, part A says state the largest value of C such that g of f of x exists. So hopefully it's something that you guys remember now. The range of the inside function has to be a subset of the domain of the outside function. So range of f in this case, because f of x is inside, range of f has to be a subset of the domain of g. Now, the domain of g is not actually given to us directly, and I've done that on purpose because I want you guys to figure it out. It's pretty straightforward anyway. It's just 0 to infinity. But it's just a little bit of extra work that you guys have to think about or guys have to do. Cool. Now, if we want the composite function to exist, we need the range of f to be a subset of 0 to infinity. So the range of f has to be a subset like that. The best way of figuring out this question is simply just by sketching a graph of 1 minus x squared. So 1 minus x squared generally looks like this. It's just a parabola that it goes downwards and it has a turning point at 0, 1. Now, if we define it from 0 to c, then what we want is we want it to be defined from here onwards to some value c. Now, if we want the range to be a subset of 0 to infinity, though, we need the y value to be at least 0. So what we need is we essentially need the y value to stop there. Because what that'll mean is that the range of f is equal to 0 to 1, which is great because it's a subset of 0 to infinity. So if we want the range of f to be 0 to 1, what's the c value in there? The c value in there is going to be equal to 1 because the x-intercepts of 1 minus x squared is positive 1 and negative 1 if we factorize it. So therefore, c is equal to 1. Now, just a quick one with this question. It's asking for the largest value of c, and it's really interesting that they ask for that. Now, I've done this on purpose because a lot of people do see that and they get a bit confused. The reason why I've said the largest value of c is because technically you could have a c value here that it still works. So for example, if you had c is equal to 1/2, your range would still be a subset of 0 to infinity. It wouldn't be maximal. What we want to do is we want to keep as many values as possible generally with composite functions. So that's why I'm going all the way to the extreme of going to y is equal to 0 to maintain my range. Hopefully that makes sense to people. Essentially, I just want to keep as many values as possible. So therefore, I take it all the way to the axis where the y value is equal to 0 because I want my range of f to be a subset of 0 to infinity. So c is equal to 1 for f of g of x to exist. Now, part B, we have let h of x is equal to g of f of x for the value of c found in part A. So that's great. Now, part B says state the rule for h of x. So this is pretty straightforward. H of x is just going to be equal to g of f of x. So it's going to be the square root of x, but we're just going to replace x with the rule for f. So it's going to be the square root of 1 minus x squared. Pretty easy mark. Hence, show that h is equal to h inverse for all valid x values. So what we essentially do is we just find h inverse of x just by saying the inverse. And again, we swap x and y. So we end up getting x is equal to the square root of 1 minus y squared. X squared is equal to 1 minus y squared. Therefore, y squared is equal to 1 minus x squared. Therefore, y is equal to plus or minus the square root of 1 minus x squared. Now, what we need to do is we just need to reject y is equal to negative square root of 1 minus x squared, and we just have to give a reason for that. The best reason for that is because the range of this is greater than or equal to 0. So I'll just say reject the negative since outside of range, something like that. So therefore, h inverse of x is equal to the square root of 1 minus x squared, and you can clearly see that that is equal to h of x. Now, just quickly, show that questions. I forgot to mention this before, but so we've shown that algebraically h inverse of x is equal to h of x. But what have you guys seen left-hand side is equal to right-hand side before? Have you guys seen that for show that questions? Your teachers might have shown that to you before. Now, left-hand side is equal to right-hand side is great. I always write instead of that, it's an alternative. I write QED. Has anyone seen that before? Your teachers might have used it with some of their working out. Essentially, it is a Latin expression that I'm not sure what it says in Latin, but it translates to I've now demonstrated what is required, something along those lines. But essentially, it's a mathematical expression. And there's two reasons why I get students to write this one. First of all, because it's easier to remember and it's quite distinct. And also, this is like a small thing, it's like a bit of a sneaky thing. But when an examiner sees that or a teacher sees that, they're kind of predisposed to think that you're like a smarter student, quote unquote. So therefore, if they see that, they're going to think you're quite switched on, and they're more likely to, mark you positively. And they get the vibe from your working out as well to see, okay, like this person's pretty switched on. So if there's anything borderline, they're more likely to push you onto the positive side of things and give you more marks. So that's why I would recommend using the QED for any show that questions. And ideally, we should have actually done that for question one, and I actually forgot to do it. I mean, it's actually fine for this question, I'd say, because there's a significant amount of working out outside of that. But just to be safe, whatever it's to show that question, I always put QED. So, and then someone just asked me, so you would put it at the beginning, the QED? No, you actually put it at the end because you do it once you've shown what is required to be shown. Someone's asked a question, why is range greater than or equal to 0? So good question. So if you have the square root of Sienna, before I get to that, Sienna just asked what it stands for. It's some sort of Latin expression, but it just translates to something in English. I'm sure if you look up QED meaning, there'll be some sort of explanation on Google. To be honest, I'm not sure, and I'm probably going to butcher whatever I think it is. But anyway, so someone asked why is the range greater than or equal to 0? It's because when you have the square root of anything, the result is always going to be positive or 0. So if you have the square root of 1 minus x squared, it doesn't matter what's inside, as long as it's positive or 0. That's of course the implied domain. But if you have the square root of anything, then you know that that's going to be greater than or equal to 0 as a result. So that's why I knew that. And we reject the negative square root when we do our solving. Awesome. Cool. So that's the topic test done. Hopefully, I'm hoping you guys learned something from that. I'm hoping you guys had a bit of fun as well with actually just attempting the question live. I didn't want to send it out beforehand. Or someone said I think QED is equal to as required. Yeah, that's true. Yeah. Um, it's something along those lines. But yeah, no, thanks for everyone for being so cooperative as well. I really appreciate that, and I appreciate everyone's patience as well. The reason why I wanted to do the test live and split up into parts is because I didn't want to send it in advance. What I usually do with my students is to make their sessions as efficient as possible. I send it to them a certain amount of time, like a block before the class starts. So let's say if it's at 7:30, they know they're going to be sent something at 7 o'clock. They'll give it a full attempt beforehand, and then we just go straight into marking it in the class, just to make things as easy as possible. Today was cool because we got to get started and we do a bit of an intro, and then you guys go and take your time with each question. But I think for my usual classes, I usually do it in one block. Sweet. Awesome. But yeah, I really hope everyone learned something for that. And I really appreciate everyone being so cooperative as well. If people do want to, register for like full-time classes, I do have a registration link. If maybe I'll just give me a thumbs up if you kind of want to, if you want to register and you want to do this continuously, or if you have any questions, feel free to just ask away right now. I just stopped recording first of all.